Neutrons, the destructive little devils. The bottom graph, need to look at. No, it's not going to be identical to all the other neutron monitors, but they all mirror one another, which should tell you something. It should tell you that whatever affects neutrons is really Earth-wide and never specific to a certain location on the globe. Higher amounts may come in through the south or north, but you still see similar responses, although smaller amplitudes in the mid-latitudes as well. They get neutrons. Not as many. Half as many. But look, every solar cycle happens on the decade. 91, 90, 81, 80, 2001, okay? 2010, 2011. It shifted a little bit because it's really not 10 years, it's 11 plus. But you can see that every solar maximum, the neutron count goes down. At every solar minimum, the neutral count goes up. And it's like a yo-yo. Hello, hello, yo-yo. And look at the minimums. The minimums get lesser. Wait a minute. It doesn't mean lesser neutrons, it means more neutrons. Why? Because it's a negative scale. So when you have less of lesser, you actually have more. How confusing, but wonderful. So our minimum neutron counts have been rising, which means no, they haven't. Our minimum neutron counts have been falling. And they've been falling so much that they're now at 0, which means you're exposed to 15% more neutrons in the last 3 solar cycles than you have in the history of solar cycles. At least as far as we've been recording. Is that confusing? I really hope so, and so do they. 15%, but wait a minute. Neutrons are assigned a human harm value double of uranium, cesium, iodine, radioactive crap, you know? Protons even. Double. Neutrons, double. So if you have a 15% increase in neutrons over 3 solar cycles, then wait a minute, that's like a 30% increase. In radiation, hello, that's math. Hello. 30% increased radiation, background cosmic radiation. I wish it was a stock market. And look at last solar minimum, 2007, 2008. Weird things happened then. We lost so much ice, we freaked out. Why? It was solar minimum. Hello. Well, what happened? 7% more neutrons. We had a significant neutral helium. So you tell me what creates the neutrons. Now they say particles come from the sun. That's where most particles come from. Come from the sun. That's the only sun in our solar system. So during solar maximum we should have more particles. During solar minimum we should have less particles, because during solar maximum the sun is strong, beats back cosmic rays from outer space, expands our bow compression zone, our bow shock zone, our heliosphere expands during solar maximum. Why? Because the sun is strong. But wait a minute, during solar minimum we get a spike in neutrons. Wait a minute, wait a minute, you guys are confusing me, stop it. A spike in neutrons during solar minimum, how does that happen? NASA says more particles. Oh gosh, now I'm confused. How can you have more particles during solar minimum? Weak magnetics. Oh gosh, that's true, weak magnetics. But wait a minute, neutrons are neutral. How do weak magnetics have anything to do with it? Hello, NASA. Why do you think they put the word neutral in neutron? Or is it neutron and neutral? Anyways, magnetics have nothing to do with neutral charge. Weak magnetics lets out more particles, then we should have an expanded heliosphere. But no, we have a shrunken heliosphere that lets in what? What we do know, it lets in cosmic rays. That's what we do know, guys. We know that solar minimum lets in more cosmic rays. So when the neutrons go up during solar minimum, hey, ladies and gentlemen, where do you think those neutrons are being created? In the magnetosphere. But from what? From cosmic rays from outer space, not from the sun. Are you kidding me? We're getting cooked by outer space stuff, not our own sun. We're being cooked, neutron-wise. Cool. But now look at, like I say, last solar minimum, we had a 7% increase in the maximum. Now we're not talking minimums. We're talking maximums, an increase in a maximum, not a decrease in a minimum. We're talking an increase in a, so you add that 15%, another 5%. Actually, it's 7%, but we'll forget it. It's 20% because I can only do round numbers. So 20% increase with a double harm factor is a 40% increase in cosmic radiation coming not from the sun, coming from outer space. How cool is that? And remember, we thought this brown dwarf that's creating all this garbage, all this trouble, all this nonsense, all this controversy, all this radiation. Okay, we theorized that helium cone has shifted, and indeed we see a complete falling off of neutrons in the month of February. Generally happens in mid-February, now happen in early February. Keep an eye. Zoomed in so you guys with cell phones can see the dates. 1981 on the left, 2017 on the right, 91, 2001, 2011, solar maximum started. Guess what happened? Neutrons decreased. Yes, neutrons decreased. But each decrease decreased again. And then decreasing a decrease is an increase of the most destructive particle on the planet. So this is really significant though, guys, because I'll tell you what, we were trying to extrapolate how in the heck the CPA was getting readings of 1100 and 1200, and we couldn't even believe they would put those kind of numbers to the public record. But in order to figure out how the breakdown happened on those, you got to pay for that money. But what we can find, because we're not going to give personal information to them, we're going to actually try to figure out what's going on and how they come up with 1100, 1200 CPMs. Well, they don't want to report really where it's coming from. So first you got to pay for it and register, and they want to know who's getting that information. Number two is they don't want you to know that all these neutrons being created in the magnetosphere has nothing to do with protons coming from the sun. I mean, during CMEs and during a monster coronal hole stream, you'll make neutrons as these things slam into the magnetosphere and hit other particles that are accelerated and energized. Yes, that'll happen. But you're talking about a trend during solar max and solar min that runs opposite of what the sun's wind is doing. And they get a stupid excuse for it. Weak magnetics. Okay. So this stuff, when you look at how the EPA takes it, you look at the microsieverts as the actual radiation, the actual burning energy coming off these particles. That's what makes them harmful. That what gives them the harm value in the first place. It's what they're emitting. And you store them in your body, and then they keep emitting. But neutrons have a half-life, a fraction of what cesium is. They're giving out way more radiation. And so what happens is that they're taking the microsievert rating and using that to extrapolate CPMs that usually is applied to uranium. In other words, giving you twice the CPMs, and sometimes 3 times the CPM counts that you get from normal background radiation. Why? Because it's extrapolated from neutron radiation. Then you add the actual particle counts, because CPM stands for counts per minute. That's how many particles strike your detector. How many? In a minute. Actual particles. It doesn't absolutely measure the radiation coming from those particles. You have to convert those to microsieverts. And they have other, they have rads and all kinds of stuff to confuse you, because there's no uniform quantifying the radiation coming off a particle. CPMs measures just the number of particles. So, any instrument that measures CPMs only will not measure microsieverts. Is not telling you how much actual radiation you're exposed to, and the ones that extrapolate backwards from microsieverts are going to inflate the total number of CPMs, so they don't have to tell you the microsievert. So that will give you double of what you would get on a calculation for cesium. That gives you a total background radiations of about 800 to 1100 CPMs as recalculated from microsieverts. That would include a 20% increase in background neutron radiation. Add to that the 30 nanometer radiation that's coming when those collisions happen. Not from the neutrons themselves. They're happening throughout the solar system and in the corona of the sun. Then your microsieverts even go higher, but will not register on your CPMs because they're not particles. Confusing? Start over. Watch again. But be prepared, not scared.